You watch a nature documentary and an elephant walks across the screen. Something in your brain relaxes. Big animal, powerful animal, safe animal. Nothing is going to mess with that. Then a mouse skitters along the baseboard of your kitchen and you barely register it at all. Size reads as safety. It's one of the oldest assumptions your brain makes. But the real answer is far stranger, and it's written into the bones of the last ice age. Because if being big meant being safe, the giants should still be here. They aren't. 10,000 years ago, the world was full of animals that make today's largest land mammals look modest. Mammoths taller than a house. Ground sloths the size of a small car, standing upright to strip leaves from trees. Saber-toothed cats built like tanks with knives for teeth. Giant beavers, giant armadillos wrapped in shells like a Volkswagen. Short-faced bears that could look a modern grizzly in the eye while standing on all fours. These animals dominated nearly every continent. And then, in a geological instant, most of them vanished. Meanwhile, the small ones made it through. Rabbits, foxes, deer, rodents by the thousands. Whatever wiped out the giants left the small mostly untouched. Why? For decades, scientists have circled two competing answers, and the tension between them tells you almost as much about how science works as it does about the extinction itself. The first answer is climate. The end of the last ice age was not a gentle transition. Roughly 12,000 years ago, the planet swung through violent temperature shifts. Glaciers retreated. Grasslands that had fed massive herbivores for millennia shrank and fragmented into forests and tundra patches. An animal that needs to eat hundreds of pounds of vegetation a day cannot simply adapt to a smaller patch of grass. A rabbit can live on the food from a single hedge. A mammoth cannot. The second answer is far more uncomfortable because it points directly at you, or rather, at your ancestors. In the 1960s, geoscientist Paul S. Martin proposed what became known as the Overkill hypothesis. His argument was blunt. As humans spread out of Africa and into new continents, they encountered animals that had never seen a human before. Animals with no evolved fear of a small, slow, oddly persistent primate carrying sharpened sticks. Martin noticed something striking in the timeline. Wherever humans arrived on a new landmass, whether Australia, the Americas, or remote islands, a wave of large animal extinctions followed within centuries. Not everywhere at once. Wave after wave, continent after continent, always trailing just behind the first footprints of people. That timing is the whole argument. Climate had swung wildly before, many times, over millions of years, and the giants had survived those swings again and again. What was different this time was a new predator that had never existed before. One that hunted in coordinated groups. One that could bring down an animal 10 times its size with patience and a spear rather than raw strength. Here's where it gets genuinely strange. Bigger animals should have had every advantage against a human hunter. More strength, more mass, tougher hide. So why would the giants of all creatures be the ones to fall first? The answer sits inside their biology, and it's almost cruelly simple. Big animals grow slowly. They reach reproductive age late. They produce only 1 or 2 offspring at a time, spaced years apart. A mammoth might not have its first calf until it was 10 years old, and it might only raise a handful of calves in an entire lifetime. Compare that to a rabbit, which can start reproducing within months and can produce dozens of offspring in a single year. If a population of rabbits lost 10% of its members to hunting in a season, it could recover the loss almost immediately. If a population of mammoths lost the same 10%, it could take generations to rebuild, if it ever did at all. In other words, size wasn't a shield. It was a liability disguised as strength. The very traits that made these animals so formidable, their sheer scale, their long lifespans, their dominance over the landscape, also made them almost impossible to bounce back once a new pressure appeared. You cannot out-reproduce extinction if it takes you a decade just to raise one child. Researcher Anthony Barnowski, working with colleagues in the early 2000s, pulled together fossil records and dating evidence from across multiple continents and found that neither climate change nor human hunting alone fully explained the pattern. In many regions, the two forces overlapped almost perfectly. Climate stress was already shrinking habitats and squeezing populations. Human hunters arrived into an ecosystem that was already wounded and simply finished what environmental pressure had started. The giants weren't killed by one single cause. They were caught in a pincer, weakened from one side and hunted from the other, with a reproductive strategy too slow to escape either. Statistical modeling has added more weight to the human side of that pincer. Paleobiologist John Alroy ran simulations of what would happen if small groups of human hunters simply took a modest number of large animals per year. Nothing dramatic, nothing like mass slaughter, just steady, low-level predation sustained over centuries. His models showed that even a small, consistent harvest could drive slow-reproducing megafauna populations to extinction within a surprisingly short window, geologically speaking, while barely denting fast-reproducing small species. You didn't need humans to hunt mammoths to visible extinction in a single generation. You just needed to tip a slow-breeding population's math permanently into the red. And then, let time do the rest. This is the modern mirror, and it's an uncomfortable one to look into. The same math that erased the mammoths is still running today. Look at which species are most at risk of extinction right now, and the pattern nearly repeats itself. Elephants, rhinos, great whales, big cats. Slow to mature, few offspring, long generations. Meanwhile, rats, pigeons, and insects thrive practically everywhere humans go, absorbing losses that would erase a rhino population in a single bad year. The giants of your own era are playing the exact same losing hand as the giants of the Ice Age. Slow reproduction meeting a predator you that doesn't even need to try that hard to tip the balance permanently. There's a deeper unease hiding underneath the numbers too. It's tempting to imagine the extinction of the mammoths as some dramatic, violent event, a great slaughter visible from space. The truth is far quieter, and, in its own way, more disturbing. In most places, there is no fossil evidence of mass kill sites, no dramatic battlefield of bones, just a slow, patient erosion. A calf taken here. A herd pushed off its best grazing ground there. Multiply that across centuries, and entire species that had survived 100 previous ice ages simply run out of room to recover. That's the real answer to why the giants fell and the small survived. It was never really about size versus strength. It was about speed. The speed at which a species can replace what it loses. A rabbit can outrun extinction the same way it outruns a fox, through sheer reproductive quickness. A mammoth could outrun almost nothing except time, and time was the one thing it didn't have enough of. So the next time you watch that elephant amble across a screen and feel that automatic sense of safety in its bulk, remember what that same size cost its Ice Age relatives. Being big never meant being untouchable. It meant betting your entire species on a slow, patient future in a world that was about to stop being patient with you. The giants didn't disappear because they were weak. They disappeared because they were too big to reproduce their way out of a fight nobody warned them was starting.